Assalamualaikum and hi everyone. Welcome to our video presentation, High Performance Liquid Chromatography. What is HPLC? HPLC is the powerful analytical technique play a crucial role in separation, identification and quantification of compound in various samples. In this presentation, we will be focusing on reverse phase partition chromatography, where the mobile phase is polar while the stationary phase is non-polar. This unique combination allows for efficient separation of compound based on their polarity and interaction with the phases. In our experimental process, we will demonstrate the step-by-step preparation of the caffeine standard solution, sample preparation, injection of the work solution, and finally, injection of the sample. The identification phase involves comparing the retention times of sample and calculating the area of the peaks, which provide critical insight into the component present. There is three objectives in this experiment. The first one is to determine the retention time of a standard solution, caffeine. Second, to identify the caffeine peak in a soft drink sample. The third objective is to determine the amount of caffeine in soft drink sample using the response factor method.
Function or names of each component. Number 1. Solvent reservoir. To store the mobile phase or solvent used in the HPLC system. Number 2. Pump. To force the mobile phase flow through the packing, deliver mobile phase through the system to maintain stable flow and to avoid pulsation. Number 3. Injectors. To put sample in the mobile phase. Function or name of each component. Number 4. Column. To separate the sample components based on their interaction with the stationary phase. First type, analytical column. Second type, guide column, to increase the lifetime of an analytical column. Number 5, detectors. To measure the concentration of the analyte as it eludes from the column and passes through the detector cell. Bulk property detectors respond to a mobile phase bulk property such as refractive index, dielectric constant, or density, which is modulated by the presence of solute. Solute property detectors respond to some property solute such as UV absorbance, fluorescence, or diffusion current that is not possessed by the mobile phase.
In this slide, we will discuss the calculation of the response factor RF for the caffeine standard. The formula used is response factor RF equal to peak area of caffeine standard divide concentration of caffeine standard. The data obtained are as follows. The peak area for the caffeine standard is 6,249.49. The concentration of the caffeine standard is 100 ppm. The peak readings were obtained using a chromatography system where the detector measured the response at specific retention times. Thus, the calculated RF is 62.4949. Additional data such as retention time, width, area, and height were also recorded for further analysis. Next, we will look at the calculation of caffeine concentration in the code sample. The formula used is the same as before. Concentration of caffeine in ppm equal to peak area of caffeine in sample divided RF. In this case, the peak area of caffeine in the code sample is 7001.12. The RF used is 62.4949. The calculated caffeine concentration is 112.03 ppm. This value was obtained through analysis using chromatography. This slide shows the calculation of caffeine concentration in the Levita sample. The calculation is based on the same formula, concentration of caffeine in ppm equal to peak area of caffeine in sample divided RF. For this sample, the RF is 62.4949. The calculated caffeine concentration is 178.43 ppm. The peak area reading was also obtained using chromatography, where the detector measured the sample's response at a specific retention time. This result indicates the Levita contains a higher caffeine concentration compared to Coke, based on the analysis conducted.
The HPLC analysis confirmed the presence of caffeine in Levita and Coke based on matching retention times, approximately 2 minutes and 48 seconds with the caffeine standard. Peak area comparison using the external standard method showed that Levita contained 178.43 ppm of caffeine. In contrast, Coke had 112.03 ppm, indicating that Levita has a higher caffeine content than expected for an energy drink. The results were consistent and accurate, even though minor instrumental or sample preparation error could affect precision. Overall, the experiment successfully quantified caffeine levels, demonstrating the effectiveness of HPLC in beverage analysis.
For conclusion, the high-performance liquid chromatography HPLC analysis successfully quantified caffeine concentration in different beverages with high precision and accuracy. The retention time for caffeine in Coke and Levita were nearly identical, confirming reliable calibration and consistent instrument performance. The caffeine content result was 112.03 ppm for Coke, a refreshing soft drink, and for Levita, 178.43 ppm, which align with their intended purpose, showcasing HPLC as an effective method for determining caffeine level in diverse products. Potential error, such as a sample preparation inaccuracies for instrument factor, should be minimized in future analysis to ensure even greater reliability.